This is a simple DC motor. We have a AA battery for power and a small neodymium magnet on top of it. From this point of view, the coil is wound clockwise. We have a commutator in effect by removing half of the coating from one side of the wire. Here we have illustrated the circuit with direction of current and magnetic field. We can calculate the direction of the force on the coil through application of Lorentz force. A brush motor requires a commutator to control the flow of current through the coil. Without the commutator, the motor will experience opposing forces as it spun, reducing efficiency. Here we can see how the commutator can force a single direction of rotation. In our first panel, the commutator has the open part on the voltage source rather than the shaded part. That lets the current flow through the coil. With our magnetic field facing upward and our current either flowing in or out of the page depending on which side we're on, with the application of right-hand rule or Lorentz's force, we can see that the force is facing outward. This enforces a clockwise direction of torque and then thus rotation. Move to the next panel. Here our commutator has rotated so that the shaded part is touching the voltage source, which means that no current can flow through the coil. However, if the commutator wasn't there and it was just a single piece of wire, if we did our calculations again, our forces would still be facing outwards, but instead the torque would be in the counterclockwise direction, which would be opposing the direction we want to rotate in. Come to our third panel, and here the commutator is still blocking the flow of current. And if we had no commutator there, we would also see again that the forces would again enforce a counterclockwise torque, which should still oppose our rotation. At our last panel, the commutator is rotated such that we can allow current through again. And our forces are inward facing, but that inward facing forces is also creating a clockwise torque, which is the direction of rotation we want. Our motor needs a little bit of help to get going, so we apply a little force. And it starts spinning up. It's not the greatest of motors, but it still works.